Hello everyone, welcome back to our channel. Today's video I want to show you how you can make your keyboard. So this keyboard you can use it for computer. Right now I want to show you the part or the starting to understanding the schematic diagram part of this keyboard. Sometimes you see the keyboard but you don't know the logic behind, so that's why I'm creating this video. I tried to make this keyboard already is finished, but I need to show you every part. I was trying to make many video, many tutorial. I teach you how you can make the PCB design, how you can creating the 3D, how can creating the PCB layout, everything. So right now, before I make the small one, the small sample, but right now I make the big project. So that's why I think it's enough to show you part by part to understand, because you know everything I show. If you don't remember, you can scroll down on my video uploading on my YouTube channel, and then you can see how you can do everything. Even if you're getting any problem, you can type me, you can send email to me, or you can put in the comment. I can check and then I can give you the answer directly. So this keyboard I have two page. This page for MCU and another part for another for this is a keyboard page 2. Let's start for the page 1. Page 1, this part is part for voltage regulator. The first we need to understand the MCU. We use the MCU are using a Raspberry Pi RP2040. This one. This is a coupling capacitor. Understand this is 3 volt, 3.3. Most of MCU using 3.3 voltage. The part you can't forget to put in on MCU. If you forget this part, already your project was not working. This part of if you forget, please don't forget this part. This part is very, very, very important. Don't forget. Another part we have is the part for USB connector. This USB connector type C. When you see, we have this part is for supplying 5 voltage. This is ground, and you have another 2 pin, USB in and USB negative and positive connector. So this 2 pin is the pin for data. If you using the USB for charging only, you don't need to connecting these 2 pin. We're connecting these 2 pin because we need to transfer data, and then this one is for protection. This diode is for protection. This resistor. This I think I've told you many times. This capacitor is for coupling voltage. So another part I have here is of course I have the power resistor, power LED. This is the red indicating if the project is on, if they have power. This is the pin for, this is the red for user. This one is user RGB, because of course this keyboard are using RGB red for every key on this keyboard. They have red, that's why. And then the next part is the filter. This part is the part for debugging, for how to downloading the code to your MCU, to your project, to your keyboard. Sometimes before you see any electronic device, but you don't know You think just you putting you put, but if you don't think if there is programming, everything there is programming inside. Even this keyboard, there is programming inside. How can downloading the keyboard? How can downloading the program in this keyboard? So that's why we're putting uh, this debugging part. This is the header, normal header. This is the signal wave clock. This is the signal wave data input and output. Of course, is you see is not uh, NF. This is NF because we don't need this part on bill material. That's why it's hidden. And this is the reset button. This is the selecting button. How did this is the important part? I forget this one is from 5 voltage to the 3 voltage. Understand? And then you see another power supply here is from 5 voltage USB to 5 voltage reds. So because you have a maintain, just you have to distinguish, for this regulator, you have 5 voltage, 5 voltage from USB. This input, this is a voltage, is 5 voltage for USB. But we have reds, reds are, you see, this is the 5 voltage for reds. That's why we distinguish. You have to to make the difference for the all is 5 voltage. But it's better. It's better because when you see here, we try to converting this one from this one, you're putting resistor and the capacitor for comparing to make the difference. Uh, you know, everything must be connected in parallel. But this voltage for USB is not connected to the parallel of this one directly. Sometimes you make the, if you don't make like this one, you make any mistake connecting the voltage as in series. When you're connecting the voltage in series, what happen? All voltage is not equal. But we need to be or to make sure all voltage are equal. So that's why I make this one. I try to. And another thing is, I think, to make your circuit make nice. Just yeah. We go to the second part. I tell you, this is the red. This is the red. This is the red because for this keyboard, every every key have red. The red of RGB. Um, this is the metal hole. This is a mounting hole. I show the difference of this one metal hole and this one. This is encoder. This one is encoder. This one is encoder. And the keys, we have keys. This is a switch. Of course, keys is like switch. This is another part of switch you put in below is holding the keys. Is used for holding the keys. So I show you. I show you red. You see the you see how this is a column 0, column 1, column 2. This is a row 1, 1, column 2. Even when you go to this one, when you're checking on filter, I make this all filter is connected according to the row 1, row 0, row 1, row 2, row 3. You get it? Because you need to filter everything, this row. And then let's show you the 3D, the PCB, and show you how I make it. See, This one is our MCU. Most of part I connecting on the button. You see, this is our MCU. This is this is a vote. This is our resistor, capacitor, everything. When you check on the top, you see on the top I putting the encoder and the switch. Encoder and switch. Remote hole. That's it, I think. But you see, when you see this line and this line are not equal. Why? This is the data. This line is for transfer data, but this one is for voltage. I suggest this, if we check here for the this one is for 40 mil. This one is for 6 mil. When you're checking on the offshore website, even I will show you how you can check it. So if you don't remember, go down on the video, and then the second thing, let's show you all. You see how it look like. I creating this this is a part. This one copper legend. I creating this copper legend because this is the 3.3 voltage. So you need to creating copper for to give the larger space for this voltage. You know, when there is no larger space, it's creating electrical field. This field make short circuit on your project. Your project is not working well, so you need to make sure. Even I can show you another things. For example, here you see there is a lot of ground voltage, ground via. Why are you putting many ground via? Because to make sure there is no electromagnetic field distributed to another part. When there is electric field, it must be to go down. You know, must be to go to the ground layer. The second thing, let's show you this thing. PCB ground. This one. Yeah, go to the tool, go to the design manager, layer management. When you see here, we have 4 layers. I'm inserting these two layer in one and in two. These two layer are inserting as ground. Don't forget, I putting this one as ground because our circuit, there is, if you don't make sure you're creating the strong ground, electromagnetic field can be destroyed your circuit, make many errors in your circuit. So you have to make sure you try to minimize error. So, and another thing I can show you, it's, you see, when you go to there, it is the top layer, this is the top layer, the top. You see the inner one, inner two, bottom, inside this inner one and inner two, or ground. This circuit, this keyboard, this PCB have 3 layers. Inner 2 layer are ground. Why are you putting all inner 2 layers as ground? Because when you we're putting the enough gap between the signal on the top and the signal on the bottom to try to minimizing the noise. So electromagnetic, the field on the top, on the signal on the top, it's easy to put into the ground, in to the first inner as ground, and the signal from the bottom side it is easy to put to the inner too. That's why we try to make like this one in order to minimizing the error. This is the thing you have to understand. Sometimes before I think why the ground, or why I don't put in the ground on the bottom layer, and if I putting the signal like 5 voltage or 3 voltage, because with this one I have a 3 voltage, to have 5 voltage, another 3.3, and have a 5 for USB and the 5 for red and 3.3. So sometimes I say, why don't you putting the 3.3 on the inner layer? Imagine you putting the signal on the top layer, and then you're putting the inner one, you're putting 3.3. All is signal. It is easy to making error. All signal generating failed. So it is easy to make short circuit. So to create to remove or to prevent this error, it's easy to put in the enough ground between these two layers. Yes. And another thing, I telling you this one, why I putting this one 40 mil, and then this one is 6 mil. I telling you, and I show you the 3D. You see how it look like. This is our switch. This one, and then this one is port mount, and then this one is the mount hole. And then when you go on the button, you see most of part I putting on the button side. You see, from our MCU. Sorry. From our MCU, our resistor, lot of resistor. This is a switch. You remember this one? I connecting this one for every switch. This one is this one. Is this one, You're putting the switch on the top, and you're putting this one on down, as look like. You see, that's why I'm putting this one here and this one here. You see, I think you see the main AV I make here, I putting here many, because I need this one, this part. You remember this part. What's the function of this part? You remember this one is this part. Is part of for regulator. So that's why the regulator, sometimes regulator creating heat. So how to minimize this heat is to put into the ground. That's why here I putting a lot of here to put this one, because this part is for ground. Putting a lot of, because the signal must be go freely. They have enough space to go to an, yeah, that's it. That's it. because you have to creating a lot of this signal. If you the path is small, the signal cannot transfer freely. That's why you have to make sure the signal for the power they have enough space. You remember, and this one, the signal, the why I putting the six mil. You remember the according to the manufacturer, you have to put in the rod Z in must be 50 ohm. That's why for the 50 ohm, the line must have the 6 mil. That's why only I putting this or signal or this line or design for data transfer have 6.1 mil because we need to make sure to ensure we have 50 in Z impedance. We need to make sure the Z impedance is 15. Z impedance for 15 is 6.1 mil. That's it. So I think you see a lot of things. And then this is our red. I think you every switch they have red. This one is this one or this 1, 2, 3, 4, 5, 6, 7, 8, 9. Just check here. We have it's 9. That's it. 1, 2, 3, 4, 5, 6, 7, 8. You see? Yeah, and then this one is for booting. This switch is for booting. This switch is for the set. Yeah, and then this part is for this one is for debugging, of course. Serial data, the signal clock. This one is ground, of course. I think I tried to show you everything. If you like this video, if you like this content, if you need any help, I can put in the link for schematic diagram for whole project. I try to put in the file for whole project. If you have any problem, you can tell me. Then thank you for watching this video. Bye bye.